Hello everyone, this is Mohit Gowda, wearing the USN 1VE21CS 101. Today we are going to learn about computer networks. So, in computer networks, let's learn about sliding window protocol. The sliding window protocol is a method used in computer networks for efficient and reliable data transmission. It allows multiple packets to be sent before requiring an acknowledgement, optimizing network throughput. The sliding window is a technique for sending multiple frames at a time. It controls the data packets between two devices where reliable and gradual delivery of data frames is needed. It also uses TCP, Transmission Control Protocol. In this technique, each frame is sent from the sequence number. The sequence numbers are used to find the missing data in the receiver end. The purpose of the sliding window technique is to avoid duplicate data, so it uses the sequence numbers. So now let's see the basic concepts in sliding window protocol. Window establishment. The protocol involves the division of data into frames, enabling the sender to continuously transmit a sequence of frames without waiting for individual acknowledgements. Flow control. It facilitates flow control, ensuring that a sender does not overflow the receiver's buffer by sending too much data too quickly. Error detection. The protocol allows for the detection of errors and facilitates retransmission of lost or corrupted data. So, in sliding window protocol, there are mainly two roles: the sender and the receiver. The sender. The sender is responsible for segmenting the data, transmitting it, and responding to the acknowledgements and retransmission requests. Receiver. The receiver manages the orderly receipt of frames, requests, and transmits transmissions if necessary, and sends acknowledgements to the sender. So in this, the sender as a buffer called the sending window, and the receiver as a buffer called the receiving window. The size of the sending window determines the sequence number of the outbound frames. So now, the window size and sequence numbers. First, the window size. The size of the window determines the number of frames that can be transmitted before an acknowledgement is required. Second, sequence numbers. Sequence numbers are used to ensure that the data frames are received in the correct order at the receiver's end. So now, let's look at the sliding window protocol operation. First, the efficiency of sliding window protocol. The protocol enables efficient data transfer, reducing the need for frequent acknowledgements and optimizing network capacity. Throughput. It maximizes network throughput by allowing multiple frames to be in transit simultaneously. Reliability. It enhances reliability by providing error detection and retransmission mechanisms. So now, what is positive acknowledgement and negative acknowledgement? Positive acknowledgement, the ACK, which is the positive acknowledgement, signifies successful frame reception, promoting the sender to transmit the next frame in sequence. So it actually sends the frame in the sequence. The negative acknowledgement, the the NAK, the negative acknowledgement, indicates that the receiver has detected an error and requests transmission of a specific frame. So now, the error detection and retransmission in sliding window protocol, it actually that as we learned in the previous slide, it occurs in the negative acknowledgement. So let's see what is error detection. Error detection is a protocol which uses checksums and sequence numbers to detect errors in received frames. Retransmission. If errors are detected, the protocol triggers retransmission and requests for the affected frames. So, what are the advantages of sliding window protocol. Reliability. It ensures reliable data transmission through acknowledgement and error recovery mechanisms. Efficiency. Optimizes network, resource, and bandwidth, leading to efficient data transfer. Adaptability. It can adapt to varying network conditions, providing consistent performance under different scenarios. These are some of the advantages of sliding window protocol. Now, let's look at the disadvantages of sliding window protocol. First, the complex implementation. Implementing the sliding window protocol can be complex, especially in large network systems. Overhead. The additional control information and error detection mechanisms can introduce overhead, affecting efficiency. Resource consumption. It may consume additional resources such as memory and processing power, especially when dealing with large window sizes. So now, simplification of the advantages and disadvantages of sliding window protocol. Advantages: efficient data transfer, enhanced network throughput, error detection and retransmission. Disadvantages: potential for increased network overhead, complex implementation, increased complexity in ensuring proper window size. What are the examples of sliding window protocol? So let's look at some examples. File transfer protocols. The FTP or SFTP utilize sliding window protocol for efficient and reliable file transfer over networks. Network streaming. Streaming protocols like RTSP and RTP leverage sliding window methods for seamless data streaming. Web browsing. Modern web browsers use sliding window technique for optimized data retrieval and display. Now, let's take a look at the conclusion and the key takeaways from sliding window protocol. First, the efficiency. The protocol greatly enhances data transfer efficiency, leading to faster and more reliable communication. Reliability. With error detection and retransmission capabilities, the protocol ensures reliable data delivery. Scalability. It offers scalability for adapting to varying network conditions and data transfer requirements. Error handling. It provides robust error detection and recovery features, contributing to overall reliability. Implementation. It can be more complex to implement compared to simpler flow control mechanisms. So, this is all about the sliding window protocol. Thank you.